What if everything we thought we knew about the universe was wrong? Space is full of mysteries, but every so often, scientists find something so strange that it forces them to rethink the rules of astrophysics. That's exactly what happened when NASA's telescopes picked up something extraordinary, an anomaly so bizarre that it defied everything we understood about how stars form and evolve. At first, it looked like just another distant star, one of billions twinkling across the cosmos. But as astronomers studied the data, something didn't add up. The star's composition, its age, and even the way it emitted light didn't match anything they had seen before. It wasn't just unusual, it was impossible. NASA's most advanced telescopes, including Hubble and the James Webb Space Telescope, have captured breathtaking images of galaxies billions of years old, detected black holes swallowing entire solar systems, and even spotted planets that might support life. But this star didn't fit into any known category. It seemed to break the very laws that govern how stars live and die. So what made this star so unique? How could something exist when, according to everything we know, it simply shouldn't? The answer to that question could change our entire understanding of the universe. Stars follow rules. At least, that's what we thought. They are born from collapsing clouds of gas, spend millions or billions of years burning through their fuel, and eventually die in predictable ways. But this star, it doesn't fit any of those rules. Its very existence challenges the fundamental laws of physics, leaving scientists with more questions than answers. The first red flag was its composition. Most stars contain a mix of hydrogen and helium, the building blocks of the universe, along with traces of heavier elements. Younger stars, like our Sun, have a good amount of these heavier elements because they formed from the remnants of older exploded stars. But this mysterious star lacked the expected elements, making it more primitive than it should be, or perhaps something even stranger. Then there was the problem of its age. If it were as old as its composition suggested, it shouldn't be shining as brightly as it does. It should have burned through its fuel long ago. And if it were younger, it should have more of the heavier elements common in modern stars. It was as if this star had somehow appeared from a time when the universe was still forming. Yet it existed in a part of space where no such ancient stars should remain. Comparing it to our Sun only deepens the mystery. The Sun is a middle-aged star, stable and predictable, generating energy through nuclear fusion in a way that astronomers understand well. But this star seemed to operate under different rules. Its radiation patterns, its temperature, even the way it interacts with its surroundings, nothing matched what we expect from a normal star. Theories began to emerge, some more conventional than others. Could this be an entirely new type of star? Something never before observed? Was it formed under conditions we don't yet understand? Or, in a more speculative turn, could it be evidence of an unknown force, a glitch in the very fabric of physics? Some even dared to ask, could it be artificial? A structure built by an advanced civilization, disguised as a star? It's a wild idea. But in a universe as vast and unexplored as ours, can we really rule it out? Scientists rushed to explain this impossible star, searching for answers within the known laws of astrophysics. One idea was that it might be made of exotic matter, something entirely different from the elements found in ordinary stars. Exotic matter is a theoretical substance that could behave in ways we don't yet understand, possibly allowing a star to form under conditions that should be impossible. Another theory pointed to dark energy, the mysterious force pushing the universe apart. Could this star be influenced by dark energy in a way we've never seen before, allowing it to defy the usual life cycle of stars? Or maybe the star was simply a loophole in our understanding of stellar evolution, a rare case that didn't follow the typical rules but still had a scientific explanation waiting to be discovered. But then there were the more extreme possibilities, the poor ones that sounded like science fiction but couldn't be ignored. Some scientists wondered if this star wasn't a star at all. What if it was artificial? An enormous structure built by an advanced civilization designed to mimic a star while serving some unknown purpose? The idea isn't as far-fetched as it sounds. Astronomers have long speculated about megastructures, like Dyson spheres, hypothetical constructs built around a star to harness its energy. Could this be something similar? An ancient relic of a civilization far more advanced than ours? Even stranger was the idea that this star might be a cosmic remnant from a universe before our own. Some theories suggest that our universe isn't the first, that it was born from the ashes of an earlier cosmos. If true, could this star be a leftover fragment from that previous reality, somehow surviving the birth of our universe? It would mean that the laws of physics themselves might be different in ways we never imagined. The biggest question remained: was this a one-time anomaly, or was it a clue to something much bigger? If we found one star that defied explanation, could there be others? What if we were missing a fundamental piece of reality, something so big that it would rewrite our entire understanding of the universe? The search for answers had only just begun. When news of this star reached NASA and the global scientific community, reactions ranged from deep skepticism to sheer excitement, and maybe even a little fear. At first, many astronomers assumed it had to be a mistake, perhaps an error in the data, a miscalculation in the telescope readings, or even an undiscovered type of cosmic illusion. But as more observations confirmed the star's existence and bizarre properties, it became clear that this was no ordinary celestial body. This was real, and it demanded an explanation. NASA, along with other space agencies, quickly mobilized their most advanced telescopes to study the anomaly. The James Webb Space Telescope, with its ability to peer deep into the cosmos and analyze the chemical makeup of distant objects, was directed toward the star. Ground-based observatories like the European Southern Observatory's Very Large Telescope and powerful radio telescopes around the world joined in, searching for clues in different wavelengths of light. Was the star giving off any unusual signals? Was it surrounded by structures or energy patterns that didn't belong? Every detail mattered. Theories were tested, debated, and torn apart. Some scientists saw it as a rare, one-in-a-trillion anomaly, something that would eventually be explained by an overlooked quirk in stellar physics. Others believed it was a game-changer, a discovery that could force us to rewrite what we know about how stars work. And then there were the more speculative thinkers, the ones who whispered about artificial origins or the possibility that this star was a message from the cosmos itself. Regardless of what the truth turned out to be, one thing was certain: the search for answers was just beginning. If this star truly broke the known laws of physics, it could mean that our understanding of the universe is incomplete. It could lead to new discoveries, new technologies, even new ways of thinking about reality itself. Could this be the first of many? Could there be other stars like this, hidden among the billions we've yet to fully study? If so, we might be on the verge of a breakthrough that will redefine astrophysics as we know it. This wouldn't be the first time astronomers have stumbled upon a star that didn't quite make sense. Throughout history, strange celestial objects have forced scientists to rethink the universe. Take the so-called Methuselah star, for example. At one point, its estimated age made it older than the universe itself, a paradox that baffled researchers for years. Or consider Tabby's star, which exhibited mysterious dimming patterns that some speculated could be caused by an advanced alien megastructure. Time and better data eventually provided explanations for some of these mysteries, but others remain unsolved. Could this newly discovered star be part of a pattern? If this is not the only one, then the implications are staggering. A single strange star might be an anomaly, but multiple unexplained stars? That could signal something much bigger, a fundamental gap in our understanding of astrophysics. It could mean that our models of star formation, nuclear fusion, and even the forces governing the universe are incomplete. What if entire classes of stars exist that we've never categorized? What if there are forces at work? Dark matter, dark energy, or something even more exotic that shape the universe in ways we've never realized? The possibility is both thrilling and unsettling. If we're standing at the edge of a major discovery, it could change everything, from the way we study space to the way we think about our own place in the cosmos. It could lead to new physics, new technology, or even the first undeniable sign that we are not alone in the universe. For now, astronomers will continue pointing their telescopes toward the unknown, searching for more signs of the impossible. But the question lingers. What if this is just the beginning? What if we are on the verge of a cosmic revolution, one that will force us to rewrite everything we thought we knew about the stars?